My name is Madeleine Mack, and this year my project is evaluating multiple strains of insulinoma in order to determine which cell line would be most viable for an insulinoma transplant in a C57BL6 mouse. The goal of this experiment is to create a new way to manage and treat diabetes. 38.4 million people in the United States alone suffer from diabetes. My mom has had diabetes since I was born. This project aims to build on islet cell transplantation. The insulin-producing beta isolates are transplanted from a donor or from stem cells into a diabetic person. Many issues with autoimmune reaction and adenotoxic anti-rejection medication prevents islet cell transplantation from being effective. Now, why is the strain of insulinoma important? In a transplant into an animal model, it is crucial to make sure that the injected cells will not overcome the immune system. Since they are tumor cells, insulinomas can cause hypoglycemic emergencies if they secrete insulin too quickly. Thus, it's important to choose an insulinoma that proliferates slowly and secretes insulin at a slow, more constant rate. My hypothesis was that the NIT1 insulinoma would be the most viable insulinoma because it was created in order to model the specific mechanism of insulin secretion in humans most accurately. To test this, I compiled multiple public academic research papers that tested for cell proliferation rates, mitostock staining fluorescence test, and glucose-stimulated insulin secretion rates using MIN6, NIT1, INS1 insulinoma cells. Over a 3-day period, the MIN6 cells had the highest cell proliferation rate, and NIT1 cells had the lowest proliferation rate. While the MIN6 cells proliferated significantly faster, the mitostock fluorescence staining results made it clear that the MIN6 were not a viable model. The mitostock staining test stains cells for mitochondrial superoxide, which is produced by mitochondria when cells are in a state of stress. If the cell is completely unstressed, this would cause high cell proliferation and insulin secretion, ultimately rules out the MIN6 cells. Lastly, this graph compares the insulin secretion rate of NIT1 and MIN6 cells when stimulated with 20 micrograms of glucose. You can clearly see that the INS1 cells produce more than triple the insulin as the NIT1 cells for the same amount of glucose stimulation. From these results, I was able to conclude that the NIT1 insulinoma cell lines are the best insulinoma model for transplantation. I believe NIT1 insulinoma cells grow more slowly and release insulin in a more controlled manner because they maintain the precise regulation of glucose sensing and insulin secretion, responding appropriately to glucose levels. This solution has the possibility to change the worldview on diabetes treatments and help countless patients suffering from this cureless disease. This experiment has true futuristic value and can spread awareness for the medical use of cells and tumors as resources for treatments. I am currently in the planning process to execute this transplant using NIT1 insulinoma in a mouse at Texas A&M Comparative Medicine Lab. Thank you so much for watching. Bye!